Okay, we are now on section U4A5, which is magnetism and electromagnetism. Now, as we get into the last section, which is U4A6, we have to understand how magnetism works. You have to listen carefully here because I'm going to deviate a little bit from the content because I don't like the way that they go with conventional electrical flow. So just be careful when I go into something called the left-hand rule. Make sure you're following what I'm talking about, or you're going to be doing the opposite of what they're doing in the content. So when you were kids, you've probably played with magnets before. The law of magnetic poles is that opposite magnetic poles attract, so north attracts south and vice versa, and like magnetic poles will repel. So south will repel south and north will repel north. Now, if you take a magnet and you sprinkle iron filings, fine iron filings over top of it, you're going to see patterns occurring. And these patterns start at the North Pole and go to the South Pole, so they're strongest here at the ends and weakest in the middle. And these patterns actually go straight through the magnets. So they go straight through the magnets and they come back like this. So what we have is we have what's called a magnetic field, and that's going to be very important when we start to talk about motors in U4A6. So what types of things are magnetic? Well, the elements iron, nickel, and cobalt are magnetic. Now, you've probably seen other metals that you're like, whoa, 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 that's also acting like a magnet. So you have things called paramagnetism. So for example, aluminum, if you put a strong magnet near aluminum, aluminum can act as a magnet. These are the three elements that are purely magnetic. There are some that can be induced to be magnetic. Now, principle of electromagnetism, which is going to become important in motors, is that moving electrical charges create a magnetic field. So if we have the negative end here and the positive end here, I drew this to look like a pen so I could teach this. There's the negative end and there's the positive end. If I want to know what the magnetic field looks like around this wire, so pretend this is a wire going from negative to positive, I pick it up with my left hand and I curl my fingers around it. I'm hoping what you can see is that the magnetic fields go like this around this wire. So this is called the left-hand rule, and there's different left and right-hand rules out there. Right now, what we're looking at is the principle of electromagnetism. If we want to know what the magnetic field is around a wire carrying electrical current, once again, I take my hand and I wrap it around the pen this way. Now, when if we had the opposite, when if the, one thing I forgot to mention here was what you want to do is you want to put your thumb pointing in the direction of the current when you go this. So the positive is down here, so electrical current goes from negative to positive. Now here's where I differ from what your content is saying. Your content is going with conventional electrical flow, which is wrong. It's when they used to think that electricity went from positive to negative. So then they do something called a right-hand rule. Don't do that. I'm going to make the test around the left-hand rule. Left-hand rule. Now, if the positive is here and the negative is here, and you want to use the left-hand rule, you've got to get it so your thumb is pointing in the direction of the current, and now you grab the pen. So I make the wire look like a pen. So I've got this end of the pen down here and the other end is down here. I grab it so my thumb is pointing towards the positive, and that shows you the flow or the electrical current. This shows you the magnetic field with the fingers right here. So the magnetic field is going to start on this side and come this way. It's going to start on this side and come this way. This side and come this way. Quickly, one more time. I know my current is going from negative to positive. That's the flow of electrons. The pen is my electrical wire. I pick it up so my thumb is pointing with my left hand towards the positive end, and this shows me my magnetic field. My fingers wrapped around here show the magnetic field. They're coming over top. They're coming over top. In this case here, I take my left hand, so my thumb is pointing towards the positive, and now my magnetic field is coming this way. So it's coming from the opposite direction. So I tried to draw this to show that the field is going in behind and coming over top. When you get to solenoids in here, I don't want you to worry about any of the rules. All I want you to understand right now is what a solenoid is. So we're not going to look at the magnetic fields around a solenoid. That's in content section 4. Ignore the last part here. Here's what a solenoid is. To intensify the magnetic field, we can wrap wire in a helix. So this is going to be wrapped in a helix. So if we took an iron core of some type, so just a piece of iron, and we took our electrical wire and we wrapped it around in a helix real tight, this is very important in electricity. It's called a solenoid, and it creates a very powerful magnet. So if we had one end attached to the negative terminal, and we had another end attached to the positive terminal, and we ran current through this wire, the more current we ran, the stronger this electromagnet would be, and we could pick up metal objects with this electromagnet. Okay, make sure you take the time to look up solenoids on YouTube, look at what a solenoid is, and watch it pick up some things as you make a powerful electromagnet with these solenoids. Please ignore left-hand rule and right-hand rule when it comes to solenoids. All you have to know is what a solenoid is.